So we'll spend today and tomorrow on 8.4. Today's rational expressions. We are going to be multiplying rational expressions. What you do today kind of hinges on what you've learned about fractions in the past. So without a calculator, you need to go ahead and simplify 4/8 over 12/35. Let's see how we did. First thing you should do, always look to reduce your fraction. So 14/8. What goes into both 14 and 8? 2. How many 2's go into 8? And how many 2's into 14? 7. Good. Then you're looking here. Can you reduce this way? Anything that goes into 12 and 35? Nothing. Anything that goes in any top with any bottom. So like cross reducing. 7 and 35. What goes into both? 7 goes into 7 and into 35. 5. And 4 and 12? 4 goes into 4 and in 12. 3. So we now have 1 over 1 times 3/5, or 1 times 3 and 1 times 5. The answer is 3/5. Okay, any questions? My expectation as a teacher is you know how to do that. If you do not know how to do that, you better learn quickly and make sure you're asking lots of questions, because we are not going to be simplifying basic stuff like that. We're going to be simplifying more complex stuff like the stuff on page 371. Okay, so let's take a look at that real quick. This is page 371.
Oh boy.
All right, first of all, number 3 says, why does the solution for example 2 exclude x equals -4? So we've made a big jump all of a sudden from this to this. This is a fraction. It has been factored on top. X plus 5 times x plus 5 makes x squared plus 10x plus 25. And x plus 4 times x plus 5 makes x squared plus 9x plus 20. Hopefully you could factor that quickly and get it to this form. The question is, why can I never have x equal -4 or -5? Okay? Now we're not reducing there. However, pretty good question. Why don't you talk to your neighbor about it? Wrap up discussion. Volunteer. Trevor.
Because the denominator would be 0.
Good. Our denominator would then be 0. Well done. So if you have x equaling 0 or x equaling -4, you would have 0 times -4 plus 5, or 1 in that case. But the answer is 0. You can't have that. Okay? That's if x equaled -4. Okay, you get a 0 on the bottom. If you had x equaling -5, you would end up with -1 times 0. Okay, you would have a 0 on the bottom again. -1 times 0 in that case, you'd still have 0 on the bottom. You can't have that. So that is called a restriction. Okay, when we simplify this, first thing that we could do after we recognize, hey, x cannot be -4 or -5. It can't be either of those. That's a restriction. We then look to simplify it. All right, tell your neighbor how you could simplify this. All right, time's up. Volunteer, how do I simplify? Alyssa.
The x plus 5's cancel out on like the one on the top and then the one on the bottom.
Good, these two pieces will cancel. We can cancel them because there's multiplication symbols. You're multiplying by this quantity, so you can cancel quantities. I'm then left with x plus 5 over x plus 4. That's the simplified version where x cannot equal -4 or 5. Okay. How do you think you got that? Okay, so we've simplified a fraction. We reduced it. All right? Okay. I want you guys to try number 4, A, B, and C. Give you guys about 5 minutes to work on them. Go. How many have finished A, you think? How many have finished B? Okay. How about C? Got about 3 more minutes. Talk with your groupies. Okay, get to a good stopping point there. All right, letter A. First thing you could do, looking at just the number part, what goes in negative 27 and 9? Biggest number. 9 does. 9 goes into 9 once, and in 27, negative 27, negative 3. So on top, from that piece, we end up with negative 3. On the bottom, we end up with a 1. That is quite blurry. A little better. Okay? Where do you have more x's? Top or bottom? Bottom. This means you have x times x times x. This is x times x times x times x. Okay? Each one cancels 1, so we're left with an x on the bottom. We have 1 more on bottom. Okay? Where do you have more y's? Both equal, so they cancel. My solution is negative 3 over x. How many got that part? Okay? What's the restriction? Tell your neighbor. What can x not equal?
0.
X cannot equal 0. X cannot equal 0. All right. Any questions there? Yeah.
Wouldn't there also be a restriction against y equaling 0?
Y could be 0 because you could have 0 on top. Oh, hold on. I didn't see the 0 down there. Yeah. Good call. Y cannot equal 0 as well. I didn't even notice that I crossed it out. Good call. Y cannot equal 0 either. Any others? Any other questions there? Good job, Lee. Letter B. Tell your neighbor what you got again. Refresh their memory.
I did not get.
Okay. Need your attention back up here. So what ends up happening when you get to these more complex problems, some people have a hard time finding an entry point, like how to even begin. So what do you, how did you guys start this problem? Those of you figured out. Yeah. Factored top and bottom? Bottom. What does bottom factor to? X minus 3, x minus 2. Now be careful with 5s and 6s because some people would use 6 and 1 there. Okay? So 2 things that multiply to make positive 6, so that means the signs have to be the same. Okay, and add to a negative. All right. Okay? Question?
And then when you're like looking at the top, could you rearrange that? Would that work?
Yeah, you could. You could rearrange it as
X minus 2.
negative 3x plus 6. Let's start with that. Okay? So if I now have negative 3x plus 6 over x minus 3, x minus 2, can I factor the top? Okay, what can I take out?
3.
I can take out negative 3. If I take out a negative 3, then I have a positive x in front. Okay? So if your a term's negative, try to take out a negative. That ends up being negative 3 times what is negative 3x? It's x. And negative 3 times what is 6? Negative 2. So we've now canceled that. Or, excuse me, factored that. Okay? And so from this piece right here, first, what are your restrictions? What could x not be?
3 or 2.
3 and 2. Okay? And what can I reduce or cancel? X minus 2's. Okay, I could cancel because there's a multiplication symbol. If it was addition there, we couldn't. Since multiplication we can. I'm now left with negative 3 over x minus 3. Can I cancel the 3's?
No. Implied parentheses.
Yeah, there's implied parentheses here. This, you have to cancel the whole bottom if you're going to do that. You can't cancel that 3. Here, the reason we could cancel this because you're multiplying. Here, we're not multiplying. We're adding a negative or subtracting. You cannot cancel the 3 there. That is our reduced form, and we're golden. How many made it that far on it? How many know where they made their mistake and got stuck? That's the goal of them. Okay, any questions? Letter C. Factor top and bottom. If I factor bottom, what do I get? Exact same thing, right? Okay. Can I factor the top?
Yeah.
Yes.
Yeah. What's it become?
X minus 2 is 2x plus 1.
X minus 2, 2x plus 1. Okay. How many got the factored form? Okay. What could x not equal?
3 or 2.
Okay. Same restrictions again. Okay. And in this case, can we cancel anything?
Yes.
Yes.
X minus 2.
Yeah. There we go. So a reduced form is 2x plus 1 over x minus 3. Can we cancel the x's?
No.
No? Tell your neighbor why you can't cancel x's. Okay, implied parentheses, right? You've got to do what's on top or bottom first, or cancel the whole quantity. Yes?
So when we're finding the restrictions, do you want us to find the restrictions right after we factored, or do you want us to find it after we
You can find them anytime you want. I personally find them right after I factor. However, you could find them at the very end. You just got to remember if at any time that a value of x or y makes the bottom 0, you have to put it in, even if you cancel it out. Okay? All right. So tell your neighbor what 3 and 2 would be if you graph this. Okay, let's see if we can remember. What is 3? Everyone, what's 3? It's an asymptote. What's 2? It's a whole. Now, many of you missed that on your quiz. Class average on the quiz is about an 81 or 2, which isn't a horrible average, but for our class, when we're usually upper 80s, lower 90s, that's not our best. It's higher than previous years, where there was at 80, so that's good news. However, many of you missed this. When you cancel something, it's a whole. When it remains, it's a asymptote. Okay? All right.
When will we be getting the quizzes back?
You'll be getting them back at some point. Not today. All right, page 372. There you got it. Number 5. For which values of x is the product in example 3 not defined? Justify your reasoning. And then number 6. Multiply those two and simplify. All right, let's see on number 5. What will make x undefined, or what could x not be?
And 4.
Okay, what do we get from here?
4.
4. What do we get from here?
-3.
And here?
5.
-5. X could not be those values. At any point, that would make the bottom become 0. Why? Because over here, you'd be multiplying by something undefined. Or if you multiplied first, okay, you'd end up with a denominator of x minus 4 over x plus 3, or times x plus 3 times x plus 5. Okay, and none of those things could be zeros. Okay, that still won't focus. Let's talk about number 6. Well, any questions on 5? Hopefully restrictions aren't too bad. Number 6, you're multiplying those two pieces. So, first thing you did, tell your neighbor what you did first on it.
Factor them.
All right, volunteer, what'd you do first? You can't just shut down and not do it. So, you got to try something. Lee, what'd you do?
I factored all the ones that could be factored.
Factored everything you could. So can we factor this? Yeah, hopefully it's as quick as you recognizing that's a plus 2, a minus 2. How many had that factored that quickly? Good, that's difference of two perfect squares. We want to be to a point where we recognize perfect square, difference, a plus 2, a minus 2. Okay? Difference of two perfect squares. Square root a squared is a. That's 1, so a plus 1 and a minus 1. Could you use the sum of two perfect squares and use this pattern? No, you can't. Okay? All right, so if that was a plus sign, you couldn't do it. All right, can I factor a plus 1?
No.
It's already factored, I guess, if you want to think of it that way. There's nothing to factor there. Okay, can I factor here?
Yes.
What can I take out?
An
A, so that's a plus 2. Okay, how many had that? Made it that far. plus u squared. Whatever that was. All right. What could a not equal?
Plus or minus 1, 0, and 2. Negative 2.
Negative 1, 1, 0, negative 2. So a cannot equal plus minus 1, 0, and negative 2. Those are the restrictions. Can we cancel anything?
Yes.
Yeah. Tell your neighbor what you cancel.
A plus 1.
Okay. Cancel a plus 1s. Cancel a plus 2s. Anything else? Can I cancel a and a?
No.
No, they're in quantities. How about this a and that a? No. So when I multiply straight across, I'll go this way. A minus 2 times 1, essentially, is a minus 2. On bottom, a minus 1 times a is a times a minus 1. Remember, we can't cancel here because that's implied up there. Now you could write it like that, or if you want to multiply it out, you can. I just leave it in factored form, but you could say a squared minus a. Either way. There it is. Once again, can't cancel a's because they're implied parentheses. You have to take the whole piece. Any questions there? How many are able to get that one? Okay. How many know where they got stuck? All right. Last two. While you're working on these, I'll hand out your assignment. Number 7, for which values of x is the quotient not defined? Justify, and then divide. Be careful. You're dividing now, not multiplying. Yes, this is 5 times x minus 4. Thanks for asking. Good question. Okay, how many got those restrictions for number 7? Negative 2/3, 2 and 4. Did I forget 0?
Yeah.
Where's 0 at?
Oh wait, no, that's not an X. Wow.
Oh yeah, we'd have to have an x here. Yep. So that would negative 2/3 would make this 0. Subtract 2, divide by 3. 2 would make that 0, and 4 would make that 0. So since those will all make those zeros, those are our restrictions. Questions on 7? Everyone rate yourselves 1 to 5 on restrictions. Where are we at there? Know how to find them? Okay. Tyler, Cole, how are you guys doing? Okay. All right. You're a 1? Okay. Oh, it's just thumbs up. Okay. All right. All right. She was blocking. She was a blocker. Yes. She's a pretty good blocker. All right. I'd blame her too. Okay. A squared plus 2a minus 15 over a squared minus 16 divided by a plus 1 over 3a minus 12. Now, some students like to factor first. I personally like to deal with the division symbol. We don't usually divide fractions. Our minds function a little better in the mode of multiplication. So we are going to multiply by the reciprocal. Now, I realize some of you may have been taught earlier on in elementary school that when I divide fraction, I just cross multiply. I would suggest you do not use that method. Okay? That will mess you up more than you know in the long run. Rewrite it. Maybe as you're writing it down, write it like this, where you actually just flip this and it becomes multiplication. Okay? How many remember that rule? Okay, that's all from dividing fractions. Just multiply, change that to multiplication, and flip. So don't touch, multiply, and flip. Okay? Don't touch, multiply, flip. That was what my 5th grade class came up with back in the day. They're now old. Okay? So, they're like almost 30. Old. All right. What's this become? Plus u? A plus 4a minus 4. All right. That stays. What do we take out here? Everyone? 3. 3 times a minus 4. We'll make that a 4. And there we go. Check out that artwork. All right. How about here? Two things to multiply to make negative 15. Add to 2.
Negative.
A minus 5, a plus 3. A plus 3. It would be a plus 5 with a minus 3. That would be minus 3.
A minus 3, a plus 5.
Because the 2 is.
Yep.
I thought it was a negative.
It's a minus 3. Unbelievable. All right. Just trying to mess me up. That's okay. All right. This is our a minus 4. It does not look like a minus 4. Let's move that minus sign up. Okay. A minus 4. That cancels that. Okay. Anything else cancel?
Nope.
No. Pretty ugly.
We have left on top a plus 5 and a minus 3.
Can't see.
Thank you.
Times 3.
All times that 3. And over here we have a plus 4 and a plus 1. Restrictions, a cannot equal plus minus 4. Don't forget about the one we canceled. And negative 1. Okay, how many got it right? How many would have got it right if you remembered to change it to multiplication and flip?
Yeah.
Okay, very good. Any questions? All right, you have your assignment. Please take a look at it. Example side today, 3 through 22.
Wait, there isn't 20.
Okay, let's go 3 through 20 then. Don't you feel better? All right. Oh, yeah, it was 3 through 22. We just changed 3 through 20. You just skipped 2 problems. You're welcome. Hey, anything I can do to help you? All right, 3 through 20. You can skip those other 2 that I had said. Okay, everyone's taking a look at number 9. Done?
I'm actually so confused, so I'm just gonna do a repair when you hand them back.
Okay. Just set it on my desk there. Hey, right here. Can I factor that? Well, is this a perfect square?
Yes.
Everyone, is this a perfect square?
Yes.
Is this a perfect square?
Yes.
Is this a different sign?
Yes.
This is the difference of 2 perfect squares. The pattern for difference of 2 perfect squares. You have a plus and a minus. You take the root, square root of x squared, and square root of y squared. Okay? Hey, you got to recognize it. So those of you who are like, oh yeah, I get it now, add it to your notes because you won't get it in 2 days. How do you do the top? You guys factored like that earlier this year.
I remember that.
Oh. Did you add it to your notes? Is the question. Hey, this is a perfect square trinomial. No, actually, it's not a perfect square trinomial. However, if you ignore, let's look at the pattern real quick. My assumption right now is that you're going to add this to your notes, and I know what they say about assuming and stuff. However, I expect that you're actually doing it. If you don't, you will miss it on your quiz. Okay? So, you begin with a squared, you end with a squared, a y squared, and in between you have the xy. Okay? So, in this case, we could think of this as just being x squared minus 6x plus 5, just to make our life a little easier for a minute. 2 things multiply to make 5 and add to negative 6. Okay, x minus 5, x minus 1. All right? Now, if I'm going to get a y squared at the end, what has to be in here? Okay, that now gets me to here. Okay, so x times x is x squared. X times negative 1y is negative xy. Negative 5y times x is negative 5xy. So that now gives me negative 6xy's. Okay, and positive 5y squared. All right. So really, if you think of this without the y's, as long as you end with a y squared and have a y here, then you can do that. Now, if there wasn't a y here, you couldn't factor it. Or if this was just a 5y at the end, you couldn't factor it. You've got to have the y squared at the end and a y in the middle. Okay?
Yeah.
Any questions there?
No.
Add it to your notes. Add that piece and that piece to your notes. Make sure it's in there. Good questions. Keep asking them. Right. So the next question came up is if someone else can ask it besides Lee or Gabby or Alyssa or Bella, because they're all the ones that potentially probably could have heard Lee, then I'll answer it to the whole class. What's the next question that should come up in this problem? Now, hopefully you know what to cancel once you get it factored. Cole? Yeah, what are the restrictions? Okay, how do I find them out? I don't want to know them. How do I figure them out? Yeah? Set each part equal to 0. X plus y equals 0. What can x not be? Good, you get x by itself, right? How do we do that? Subtract y. X cannot be the opposite of y. Here, x minus y equals 0. What can x not be? Okay, x cannot be y. Those are my restrictions. X cannot be y and x cannot be negative y. So x cannot be plus minus y.